Hello all, welcome to the first two labs of your ocean engineering marine instrumentation course if you are doing your undergrad or this is also included for the experimental methods people in the MTech. This lab consists of two big parts. The first big part consists of is made up of instruments that you normally use in an instrumentation laboratory. You look at instruments such as the oscilloscope, multimeter, you'll also look at the function generator, and you look at the basic power supply. The second big part is actually where you get to work with an instrument. The instrument in our case for this lab is the tilt meter that is there. With the tilt meter, you will do a calibration exercise, and you'll also look at a very tiny video showing the tilt meter in action, where they put it in the ocean engineering lab, and you'll see that they're making the ocean engineering tank, and they'll be doing measurement exercises with I think a structure that they put in the water. Okay, but anyway, with the tilt meter here, you'll just be doing a calibration exercise. Okay. So now you'll see a video that we recorded with the lab instructor, Mr. Prabhu, speaking and just showing the various controls, how we do the experiment, etc. Thank you.
Good evening, sir. This is a demonstration about our basic instruments which are handled in BTech and MTech laboratory classes. Okay, first as a basic instruments, we are going to look into the digital storage oscilloscope. So, which means it is a device, it can able to view, read as well as store any signals. Okay, initially just I am going to switch on the device. There is a some OS inbuilt is there. So, based on the after booting the OS, the display will be reflected. After reaching the display only, our features and the option and configuration will be enabled. So, now our home screen is started. So, initially the storage device, the device we can say as a one of the data acquisition system also. This is run stop button is nothing but if we want to pass any signal, we can stop or run the signal. So, once it stop, it will glow as a red button. See, apart from if we want to reset our digital storage oscilloscope, the device has a 4 channel. Each channel, individual channel, the amplitude can be varied for each and individual channels, as well as the time series will be for the 4 amplitude channels. It's a common, so we can vary through this knob. Secondary, the home position we can change through this knob, as well as finally for mode of coupling and measurement signals and data accuracy signals, all those things will be there. This is the maximum measurement voltage of plus or minus 20 volt in the frequency range of 70 megahertz. Okay, and also the device has a storage location. See, by using our thumb drive, we can store our data. The thumb drive location will be here. After recording the data, we have to insert our thumb drive here. So, the thumb drive will be in FAT32, it should not be in NTFS file folder. So, once after inserting the thumb drive, in your display itself, it will show, it will detect our thumb drive. Then finally, there is one option will be there. Here save and recall option will be there. Once when we are going to press this save and recall option, there will be a store button will be displayed. After pressing the storage button, the data is going to store in our thumb drive by default name. Okay, it may be A, B, C, D or else X1, X2, X3. In the name of that, it will be stored. The format of stored data will be in our Excel format. There is one option is there, is auto scale. If you press the auto scale, so the initial default setup will be loaded. So, once the setup is loaded, after auto scale, we can configure according to our needs. Store the format of data will be in Excel format. So, this is the basic details about the digital storage oscilloscope. After this, by using function generator, just we are going to connect the function generator with this device, then I am going to feed each and every signal, then it can reflect how the DSO will be read and reflect the data. Okay, just I am going for the next data. Our next instrument will be the function generator. So, the name itself, it will come different kind of functions like our sinusoidal, triangle, square. Those signals we can generate with our customized amplitude with the time series. So, that also we can utilize for our multiple purpose. So, now how the system is working, what are the functions it is and what are the features it has. So, now I am switch on the device. Once the device is booted, the initial home screen will be reflected. In this, by default, signal which is enabled, that will be reflected on the home screen. See, apart from in the function generator, it has the maximum frequency level of 25 megahertz. Okay, yes, zoom money. It has a maximum frequency level of 25 megahertz. So, up to that you can able to generate and feed the signal. Okay. So, in this, the bottom we have there are 4 to 5 individual buttons. So, each button itself, it shows what kind of signal you can able to generate. So, first will be the sinusoidal, second will be the square, it is a ramp and it is a pulse, and this two will be the same pulse with the different combination of amplitudes. That is it. Yes, sir. So, apart from here, there are two channels is there. This is our output channels. When we need the output, the on off button is already is given. So, once after configure our amplitude and frequency level, just we can on or off the signals. The on off signals will be read through some other digital storage oscilloscope. See, apart from channel 1, channel 2 selection button is already is there. If you want both, that option also is there. So, now simply I click the sinusoidal, and with this I can able to give my pointed things. Here I can able to feed my what is the data I want to give. I can type, just I will simply if I switch on and switch off, it will generate the signal. That is it. There is no future in this. Only the device can help to generate different type of waveforms with the customized amplitude and frequency. That is it. Initially, we have seen that basic instruments, just like a DSO, it's a digital storage oscilloscope, as well as we have already seen that function generator. Okay. Now, how the function generator is generating output signal, that signal just we are going to obtain through the DSO. So, here I am going to generate few signals and I am going to vary some frequency levels. It will be displayed in the digital storage oscilloscope. Initially, I set it the sine wave in the frequency range of 50 hertz. The amplitude will be 1.9 VPP. So, now the signal is displayed from the FG to DSO, the signal cable connected to the banana clips. It can be say as a BNC cable also. So, the BNC to BNC, it is integrated to FG to DSO, the signal flow through this one. So, next I am going to generate the square wave with the same configuration. Now, in the square wave, I am going to increase the frequency level, the frequency value of I am going to 100 hertz. See, there are the higher frequency, so our waveform will be like that. So, if I am reducing the frequency level, the range of 25 hertz. So, our signal now it's very clearly seen. So, like this, any signal, not only the sine, the same configuration is a sine, it's a square, it's a ramp signal and pulse. Maybe the any configuration we can generate and we can look, we can see. The same position we can increase the frequency there are the few more options is there, millihertz, hertz, kilohertz as well as the megahertz option is there. Which are the things our required we can enable. Now I am giving the range of 50 hertz. So, now it is modified. In the same manner, we can increase the amplitude also. So, we have the physical button to set the value as well as we have the rotatory knob here to change the amplitude or else reduce the amplitudes. So, here by default value I fixed the range of VPP will be 2. Frequency 50 hertz. The same I am going to measure through the DSO. Here there are the option is there to measure. So, once you press the measure, by default scaling will be appear. In this, the first will be the frequency 50 hertz. There is some due to some noise, it will be changing 49.95 or 50 or something. Our peak to peak value will be near to 2.0. It's changing frequently 2.0102 or something. It is some wiring error something. But our what are the input feeding through the function generator, that is can be displayed in the DSO as well as the same data can be read through the DSO itself. The same data can be saved through thumb drive also. That's it. This is our third basic instruments. So, first we saw the DSO, second we saw the function generator. The follow that we are saying that power supply. This is a DC power supply, which means the direct current. Okay, it will help to activate more of our electric circuits, electric or electronic circuits. It help to activate the circuits. Okay, so this is the basic simple on off switch. So, whenever we need, we can switch on and switch off. The capacity of the power supply will be 0 to 30 volts, the maximum amps rate of 3 amps. Apart from the power supply, it have the feature, it can able to set any customized voltage. Suppose if you want to set any 15 voltage by default, that voltage also we can set and fix it as a memory location. So, whenever we can recall the location, it will by default it will discharge only the 15 volt. So, not only the 15 volt, 0 to 30 any voltage we can customize and as we can set it as a default one. Okay. and this is our output terminal. The black one will be 0, the red and green will be the plus 15 and minus 15. So, our required voltages we can obtain through this terminal. After connecting this, even the switch is on, by mistake, by humanity mistake, sometime the voltage will be discharged. To avoid this, there is a one more safety features they are given, is a on off switch. After customize all those things, whenever our circuit need to be activate, that time only we can able to switch on and switch off this button. Then only our customized voltage will be discharged through this output ports. So that's it. This is the simple power supply system. That's it. See, initially we look after that basic instruments, and finally we come to that sensor points. We have different types of sensors for different application. Now we have here inclinometer. The inclinometer, it consists of two axis inclinometer, either x as well as the y direction inclination we can measure. The company name of Postal, the range of plus 10 to minus 10. So, our required position we need to be fixed, whether if we need x or y, based on the location position we have to fix it any surface. This is our inclinometer OEM connectors. So, it connectors, it have the port of including the excitation voltage to the sensor as well as the output port for x and y axis. So, all four will be inbuilt. So, the only one connector will be used for giving the excitation voltage as well as the output terminal. So, just I am simply connecting now. It has the rotary mechanism device. So, just lock and lock with thread mechanism. That's it. Okay, the next basic instrument will be the multimeter. The name itself it's coming. The multimeter itself shows it can able to measure the multiple parameters like our voltage, current, resistance, capacitance as well as the frequency, and we can able to measure the microamps to the maximum ampere rating of 10 amps. The voltage it can able to measure up to 450 voltage. In DC as well as the AC it can able to measure. Now I am going to switch on the device. The first will be the AC signal measurement position. In this position we can able to measure the AC voltage. Then next will be the DC. In the AC it can able to measure maximum 450 volts. Yeah. In the DC also it can able to measure up to 250 volts. Next will be the ohms, capacitance and frequency range. The multimeter can be connected through this kind of banana clips. This kind of banana clips. Here, as per standards, there is a red will be the red port, black will be going to the common port. The second end will be banana clips, or either depends upon that we can customize our ports. So, up to the AC voltage until the hertz, I already told. See, whenever we are going to measure the amps, because whenever you are going to measure the voltage, it will be the parallel, but current we have to measure in series combination. So, we have to interchange the position for the current measurement. Common will be the default one. Only this point we have to change, and which limitation we are going to measure, either we are in microamps or in amps. So, based on this we have to select the connecting terminals. So, now I am going to connect in the amps position. So, in this maximum of 3 amps we can measure the amp rating by using this multimeter. So, this is a simple device, can use to measure voltages, currents, resistance, capacitance, that is all. Okay. For the previous session, we have seen that basic instruments which are like a DSO, function generator, as well as the power supply, and we have seen one sensor, the name of inclinometer, and the multimeter also have you seen. So, now we are going to look for the second session by using accelerometer, by using inclinometer, how the inclinometer is going to calibrate it. Okay. So, now for calibration the inclinometer, we need the basic instrument which like a power supply, the inclinometer sensor, and the multimeter. For the inclinometer, the excitation voltage provided through the multimeter, the excitation voltage of 15 volts is by default set through the power supply. The excitation is already enabled. The output terminals of the inclinometer connected through the BNC cables. The BNC cable is connected into the multimeter with the mode of DC. See, now the range of inclinometer will be maximum 5, and it will come back to 0 portion, it will be 0. The inclinometer will be the 0 to 5 volts. So, initially I keep it in the middle portion in the range of 2.5 volts. For the calibration, we need this kind of tabulation. The tabulation consists of 2 parts, one will be the input, second one will be the output. So, the calibration will decide when we are going to acquire the data, the calibration data will be useful for to find the exact output we are going to obtain in the field location. Okay. So, initially now I am going to start the calibration. The position will be fixed at the center mode in the range of 90. In this 90, I am going to forward the steps of 5 degree, 95, 100, 105, 110 and 115. Again, here I took 1, 2, 3, 4, 5, 6 readings. I hope it is more than sufficient. Then I will go back into the reverse order. 1 on 5, 1 on 10, 105, 100, 95 and 90. This is only because what are the value we are going to obtain here in the output level, just we are going to cross check whether it is repeating or not, or any other minimum instrumental error is there or not, just we are going to find out. Okay. Now I start the calibration. Initial position is 90. Now I am just the initial value or note down the value of 2.44. Okay. Now I am shifting to 95. The reading will be, so now the reading will be 2.34. So okay. Now 100. So in 100 it will be 2.23. So now I am shift again to the 105 value. It is giving you value of 2.0. Okay. So the same procedure will be repeated until it can go until the same 5-degree angle, up to we can go for 0-degree position. Even at the same time you can able to see the variation of the inclination through the multimeter. Again I will come back to the position of the home position. So again it come back to 2.5. Again this is the 90 value. Again I will go for the 85, 2.58, then 80, 2.72, 65, 70, 65, 60, 55, 50. So like that we can go up to the maximum level of 5 volts. So now we can able to see the maximum range we reached as well as the minimum range also it's reflected. So that's it. So based on our noted values, we have to plot the graph for, we have the calibration data with us for the input and output. Now we are going to plot the graphs to find the calibration constant. We are going to have x and y. The x we are going to put as a input as angle in degree. In the y we are going to feed the voltage, voltage in volts. Here we started with 90, 95, 100 will be until 115. In volts we will start from 0. Based on our outputs, our data points will be start from here, the next data will be here, next data will be here, and next will be here and here. Finally, we have to integrate the lines that our data points, it will be like that. So from this straight line we can find our calibration constant for our in kilometer.